Let's remind some calculation rules. If we have the sum of two real numbers, then we can calculate the sum in any order we like. The sum is commutative. So for example, 3 plus 2 is the same as 2 plus 3. Both give the answer 5. If you have a minus b, then you should note that the minus sign is part of the number, so if you swap the order, then you will have minus b also here. In the same way, multiplication is a commutative calculation. We can multiply in any order we like. Usually we don't write the multiplication sign. So for example, 3 times 2 is the same as 2 times 3, and we'll give the result 6. Summation is an associative calculation. So for example, 3 plus 2 plus 5 would give 3 plus 7, that is 10. But we can also shift the brackets, shift the parentheses, and we would get the result 5 plus 5, that is 10. So we get the same result, not depending on where we put the parentheses. That's why if we have only summations, we can forget about the parentheses. If we would have to calculate 25 plus 87 plus 13, calculating this one here might be a little bit difficult. So instead we can calculate together 87 plus 13, that seems to give 100, and the result would be 125. In the same way, multiplication is an associative calculation. If you would have to calculate this product, calculating this product in the inside seems a little bit difficult. So instead we can take off the parentheses and we can put the numbers in any order we like. And we see that 25 times 4 is 100. We would get 1300 as a result. The distributive rule tells that if we multiply a sum, then we need to multiply all the terms in the sum. So for example here, we need to multiply with both b and c. If we had to calculate 4 times 77, we can calculate, for example, in this way. We can divide 77 as 70 plus 7. Now 4 times 7 would be there, and here would be 4 times 70. 4 times 7 is 28. 4 times 70 is therefore 280. And it seems that we will get the result 308. If we had to calculate 12 times 98 plus 12 times 2, calculating this first product would be quite difficult. But we can notice that these numbers would together make up 100. So we can use the distributive law to take a common factor in the front. We get 12 times 100, that is 1200. Also, we can use the distributive law for equations. In this second degree equation, the constant term is 0. And it seems that we can take a common factor x in the left hand side. For the left hand side to be equal to 0, we must have that one of the factors is 0. So x is 0 or x, I have made a mistake there, there should be just 2 here. Okay, x has to be 0 or x plus 2 is 0, that is x is equal to minus 2. We can solve this second degree equation by taking the common factor.